On problem number 8, we have a cable weighing 2 pounds per foot is used to lift 400 pounds of coal up a mine shaft that is 500 feet deep. Find the work done. So this one's kind of similar to the first problem on here. Not exactly, it's a little bit simpler from an equation perspective. But again, we're using the force, or the work formula. Remember that work is force times distance. So, unlike the previous one with the volume of the sphere, we integrated using the radius, or the depth of the liquid as our x that we were integrating over. In these cases where you have the cable, you still, in a sense, it's still the same thing. It's still the depth of the cable, but in this case, that's also the entire distance that you're pulling it up. So this is going to be from 0 to 500. We're integrating over that distance. So what we need to consider then is what's the force that we should be integrating from 0 to 500, and then we're going to have our work. So remember that pounds is a unit of force. So when it says 400 pounds up a coal mine shaft, 400 is just a static number in terms of the force. 400 pounds is some force that this weighs. So we don't have to put any sort of variable on that. However, the cable weighing 2 pounds per foot, we have to do that one a little bit differently. Because what you can think of is the piece of cable, the foot of cable that's already at the top. So let's say here's the cable and here's the big weight at the bottom. And this is 500 feet, we're pulling it up. This first foot of cable here that's already at the top, that only weighs 2 pounds. Or it only takes 2 pounds of force to pull that up. But then the next foot weighs that 2 pounds and the weight above it to pull it up. When you get all the way down here to the bottom, it takes the weight of all of these feet of cable to pull the bottom part up, because you have to pull all the other ones up first. So therefore, the 2 pounds per foot, you do have to put the variable on, because the distance where that foot is of cable is actually important. So if we integrate, so 400 plus 2x gives us the force necessary to pull up the weight for any given distance. So again, if this was x equals 1, it would only take 2 pounds to pull up the first foot of rope, and then 400 for the big thing. So we are integrating this from 0 to 500 because we know we're going down to 500 feet, and then we can figure out the total force necessary, or total work done to pull this up. So when we take the antiderivative of this, we get 400x plus x squared, 0 to 500. You can see that if you plug in 0, you're going to get 0. So we just get 400 times 500 plus 500 squared. In other words, 500 times 500. One way you could think about this is you could factor it out. 500 times 400 plus 500. So that's 900 times 500, which would give you 450,000. So that would be foot-pounds in the correct work unit. So there we go, that's answer choice B. So when you're doing these ones with the cable, if there's a weight at the end, you don't put the variable on that, but you always put the variable on the weight of the cable per foot.